Hello children, in this video we will learn about multiples. Raju, Pinky and Bablu have been assigned the task to collect donations to help the poor by their teacher Mrs. Khan. Raju told Pinky and Bablu a plan. He said that they would not go to the same house but go to different houses. There are a total of 21 houses in the village. Raju will go to every second house. Pinky will go to every third house and Bablu will go to every fifth house. Because there are 21 houses in the village, can you tell which houses will Raju go to collect donations from? If you wish to, you may pause the video and find the answer. Well done children, you have found the correct answer. Raju will go to collect donations from house numbers 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20. Children, do you see anything special in these numbers? Yes, we can divide all these numbers by 2. Numbers that can be divided by 2 are multiples of 2. In this way, 2, 4, 6, 8, etc. are multiples of 2. Pinky will go to collect donations from every third house. Can you tell which houses will Pinky go to collect donations from? Yes! Pinky will go to collect donations from houses 3, 6, 9, 12, 15, 18 and 21. Because all these numbers can be divided by 3, these numbers are multiples of 3. Do you know another interesting thing about multiples? We can find the multiples of any number from its multiplication table. For example, if you look closely, you will find all these numbers in the multiplication table of 3. Now, finally, if Bablu went to collect donations from every fifth house, then, can you find the multiples of 5 and find out in which houses Bablu went to collect donations from? If you wish to, you can stop the video and find the answer. Well done children, your answer is absolutely correct. We can find multiples of 5 in this way with the help of the multiplication table of 5. Bablu will go to collect donations from houses 5, 10, 15 and 20. Here, the numbers of the houses from where Raju, Pinky and Bablu went to collect donations from are written. Are there any houses in which no one went to collect donations from? If you want, you can stop the video and find the answer. Yes, house numbers 1, 7, 11, 13, 17 and 19 are the houses in which nobody went to collect donations from. But why did it happen? This is because these numbers cannot be divided by any of the numbers 2, 3 or 5. Therefore, we can say that these numbers are not multiples of 2, 3 or 5. As none of Raju, Pinky and Bablu were able to go to these houses, they took Meenu's help and asked her to collect donations from those houses. Raju, Pinky, Meenu and Bablu amassed a lot of donations through their hard work. The next day, they gave all the money they had collected to their teacher and got a lot of appreciation from her. Children, in this video we learned about multiples. In the next video, we will learn more about it through some interesting examples. Hello children! In the last video, we learned about multiples. In this video, we will learn more about it through some interesting examples. Today, Meenu's uncle has come from abroad. He has brought various toffees for Meenu and her friends from abroad. Meenu is thinking that she will divide those toffees using groups of 3, 4, 5 or 7 in such a way that no toffee is left. First, Meenu opened a packet of pineapple toffees brought by her uncle. It has a total of 49 toffees. Now, Meenu is thinking which one out of the group of 3, 4, 5 or 7 should she use so that all the toffees are distributed equally. Let's first try to divide these toffees into groups of 3 and see if there are any toffees left. How can we easily do this? Correct! We just have to see if we can divide 49 by 3. Can we do that? No, we cannot divide 49 by 3. Therefore, Meenu cannot use groups of 3 to distribute 49 toffees. And children, you remember the multiples learned in the previous video, don't you? Because we cannot divide 49 by 3, we can say that 49 is not a multiple of 3. This means which group will Meenu have to use to distribute the 49 toffees equally? To find this out, we just have to find that 49 is a multiple of which one of the numbers? 3, 4, 5 or 7? Now can you tell? 49 is a multiple of which of these numbers? If you want, you can stop the video and find the answer. Well done, children! Your answer is absolutely correct. To find 49 is a multiple of which of these numbers, we only have to see which number it can be divided by. If we look at the multiplication table of 3, 4, 5 and 7, we will find that the number 49 can be found in the multiplication table of 7 only. So, we can say that 49 is a multiple of 7. Meenu quickly made a group of 7 toffees and filled 49 toffees in 7 boxes. Now, Meenu opened a chocolate toffee packet brought by her uncle. She found 75 toffees in this packet. Now, can you tell which of the groups of 3, 4, 5 or 7 can Meenu use to distribute these 75 chocolate toffees equally? If you want, you can stop the video and find the answer. Children, you have found the answer absolutely correctly. We can divide 75 by 5. In other words, 75 is a multiple of 5. Therefore, by forming a group of 5 toffees, Meenu can divide these toffees equally among her friends. With the help of your answer, Meenu made 15 groups of chocolate candies and filled 15 boxes. Meenu finally filled all the candies in the boxes. Now, she is taking these boxes in a big bag to share them among her friends. Children, in this video, we learned more about multiples by some interesting examples. In the next video, we will look at some interesting concepts related to this. Hello children! In the last video, we learned about multiples through some fun examples. In this video, we will learn about some interesting concepts related to this. The competition, who is the smartest in Champapur, is going on. Sher Khan and Chanda have reached the last round. Both their scores are equal at the moment. The organizer of the competition, Babban, now posed this question in front of them. What number is the first multiple of any number? Time has started ticking and Chanda and Sher Khan started thinking. When the time was up, Sher Khan gave the answer, "That number itself." And Chanda could not think of an answer. Is Sher Khan's answer correct? What will we do if we want to find the first multiple of any number? Exactly! We must multiply that number by 1. And if we multiply any number by 1, the answer will be the number itself. So Sher Khan's answer is absolutely correct. The first multiple of any number is that number itself. Sher Khan is now 1 point ahead of Chanda. Let's see what is the next question of the competition. Babban asked the next question of the competition. How many multiples can any number have? Sher Khan immediately replied 12 and Chanda answered infinite. Children, can you tell whose answer is correct? We can multiply any number with infinite numbers. So, any number has infinite multiples. This means Chanda's answer is correct. Once again, the scores are equal. Now, let us see what the last question of the competition is. The next question is, which number has all other numbers as its multiples? Sher Khan immediately replied, 1. And Chanda replied, It is not possible. There is no such number. Children, can you tell whose answer is correct? We can divide any number by 1. Therefore, all numbers are multiples of 1. Sher Khan's answer is absolutely correct, that all numbers are multiples of 1. With this, Sher Khan won the competition by going 1 point ahead of Chanda. Children, in this video, we learned about some interesting concepts related to multiples. Hello children, in this video we will learn about what are common multiples. Raju has come to Bablu's house. When he reached Bablu's house, he saw that Bablu was drawing circles on some dates on his home calendar like this. When Raju asks him what he is doing, Bablu tells him that he has enrolled in a math class and his class will be every 4th day. Children, you remember the multiples learnt in the previous lesson, don't you? Can you use multiples of 4 to indicate on which dates will Bablu's class be? If you want, you can stop the video and find the answer. Well done, children. Your answer is absolutely correct. We can find the answer by using tables of 4. Bablu's math class will be on 4, 8, 12, 16, 20, 24 and 28 on these dates. Now Raju said to Bablu,
Bablu, your class is on so many days and you have also enrolled in science class. So, on what days will your science class be?
Bablu told Raju that his science class would be every 5th day. Children, can you use multiples to tell on which dates Bablu's science class will take place? Well done, children. Your answer is absolutely correct. We can find multiples of 5 in this way by using tables of 5. Bablu will go to science class on 5, 10, 15, 20, 25 and 30 dates. Raju excitedly made a mark on the calendar on the dates on which Bablu will go to science class. Now, when Raju and Bablu looked closely at the calendar, they found that on the 20th, Bablu made the circle of math class and Raju also made mark for science class in this way on 20th. Children, we can see that Bablu's math class dates are multiples of 4 and his science class dates are multiples of 5 and 20 is a multiple of both numbers. Is it possible that multiples of a number can also be multiples of another number? Yes, it is quite possible that a number is a multiple of more than one number. Numbers that are multiples of more than one number are called common multiples. Here, on the 20th, Bablu will have both mathematics and science classes. In other words, 20 is a common multiple of both 4 and 5. Children, if Bablu's science class was every 6th day instead of every 5th, then can you tell on which dates his math and science classes will be together? You can stop the video and find the answer. Well done, children. Your answer is absolutely correct. We can find the answer in this way by finding common multiples of 4 and 6. We can see that the numbers 12 and 24 are common multiples of 4 and 6. So Bablu's math and science classes will be held on 12th and 24th simultaneously. Children, in this video we learned about what are common multiples. In the next video, we will learn more about it by some interesting examples. Children, in the last video we learned about what are common multiples. In this video, we will learn more about common multiples by some interesting examples. One day, Babban monkey, Kittu kangaroo and Chanda squirrel were roaming the forest. While wandering, they got lost in the forest. After searching a lot, they found a way to get out. But to reach there, they had to cross the marsh. There are 24 stones in the marsh in this way. All three friends were very happy to see those stones. But there was another difficulty. If there are more than 2 stones on which all three friends jump, then all three will fall into the marsh. Chanda can jump 3 steps in one jump. Babban can jump 4 steps in a jump. And Kittu can jump 6 steps in a jump. Children, can you use common multiples to find out if all three will be able to cross the marsh? Let's see how we can find this. We have to first find out which stones the three friends will jump on. What will we do to find this, children? Exactly. We will find multiples of 3, 4 and 6 up to 24. Can you figure it out? If you want, you can stop the video and find the answer. Well done, children. You have found the right answer. Chanda will jump on 3, 6, 9, 12, 15, 18, 21 and 24 stones. Babban will jump 4, 8, 12, 16, 20 and 24 of these stones. And Kittu 6, 12, 18 and 24 of these stones. Now, can you find common multiples of these three numbers and find out if there are more than 2 stones on which all three friends jump? You can find the answer by pausing the video. Yes, 12 and 24. 3, 4 and 6 have these common multiples. Because there were only 2 stones on which the three friends had jumped, the three friends crossed the marsh successfully and reached the way out. Children, if all three friends had jumped to multiples of 2, 3 and 6 instead of multiples of 3, 4 and 6, would the three friends have crossed the marsh successfully? If you want, you can stop the video and find the answer. And the stones on which the three friends jump are common multiples of 2, 3 and 6. In this case, these are 6, 12, 18, 24. There are 4 stones on which the three friends would jump. Therefore, in this option, the three friends could not cross the marsh successfully. Children, in this video, we learnt more about common multiples by some interesting examples. In this video, we will learn about what are factors. Appu has decided to distribute 12 laddus to all the villagers for free today. Appu has asked all the villagers to bring boxes to carry their laddus. The next day, a long queue was formed in front of Appu's shop. Babban first gave his box to Appu. There are 12 slots in a line in Babban's box. Appu is thinking,
will 12 laddus fit in Babban's box? There is one line with 12 slots. That means 1 times 12. 12 laddus will surely fit in Babban's box.
Appu filled laddus in Babban's box. Now, Sher Khan gave his box to Appu. There is one vertical line in Sher Khan's box and 6 slots. Children, will Appu be able to keep 12 laddus in Sher Khan's box? Yes, 2 times 6 is 12 laddus can be kept in Sher Khan's box. Children, if we look closely, we will find that in Babban's box, there are 1 times 12, 12 laddus. And there are 2 times 6, that is 12 laddus in Sher Khan's box. In other words, we can write 12 as 1 times 12 or 2 times 6 in any of these ways. 1, 12, 2 and 6 are the factors of 12. Let's see who's next in the queue. Chanda is next in the queue. Chanda's box has 1 vertical line and 3 slots. Will 12 laddus fit in Chanda's box too? 3 times 4 is 12. Therefore, 12 laddus will also easily fit in Chanda's box. Or we can also say that the numbers 3 and 4 are factors of 12. Appu filled 12 laddus in Chanda's box. Children, can there be any other factors of 12? Can we write 12 as a factor of any other numbers? If you want, you can stop the video and think about the answer. No, there are no other factors of 12. 1, 2, 3, 4, 6 and 12. These numbers are factors of 12. Appu distributed laddus to all the villagers for free all day, and the villagers were very happy. Children, in this video we learnt about what are factors. In the next video, we will learn more about it by some interesting examples. Hello children, in the last video we learnt about what are factors. In this video we will learn more about factors through some interesting examples. Golu bought a box of 24 pencils from the market. Golu thought that he would distribute these pencils equally among his friends. At first, Golu thought that he would give 12 pencils to 2 of his friends. He made such a circle on a paper and wrote 24 in it. Then he made two lines on the outside of the circle in this way and two circles on the other end of it. In these circles, he wrote down the numbers 2 and 12. Children, because 2 times 12 is 24, so 2 and 12 are what of 24? Exactly, the factors. Now, Golu is wondering if his two friends will also be able to divide their 12 pencils to more friends.
My friends can divide their 12 pencils equally by giving 6 pencils to each of their 2 friends.
Thinking this, Golu made 2 lines from 12 and made 2 circles at his other end. Golu wrote 2 in this circle and 6 in this circle. Children, as you can see, what has Golu done here? Exactly, Golu has written 2 factors of 12. Now Golu is wondering if those 2 friends will be able to share 6 pencils equally. Children, can you find an answer to this question? If you want, you can stop the video and think about the answer. Yes, those friends can distribute their 6 pencils equally to 2 friends by giving them 3 pencils each. How did we find this answer? That's correct. Finding the factors of 6. Appu once again made 2 lines and circles in this way and wrote the numbers of 2 and 3 in it. Children, can this friend divide his 3 pencils equally among his friends? Yes, this friend can share his 3 pencils equally by giving 1 pencil to each of his 3 friends. Golu added it to his picture by writing the numbers of 3 and 1 like this. Children, do you see anything special in Golu's portrait? Yes, all the factors of 24 are seen in Golu's picture. Such a picture in which we show all the factors of a number by writing the factors of a number is called factor tree. Golu divided his 24 pencils equally among his 2 friends, and after giving them a picture of the factor tree, accordingly, they should distribute the pencils equally to their friends. Children, if Golu had 20 pencils instead of 24, could you make a factor tree like this for the number 20 and find all its factors? If you want, you can stop the video and find the answer. Well done, children! You have made this factor tree correctly. Children, in this video, we learnt more about factors by some interesting examples. Children, in this video, we shall see what are common factors. Bablu loves ice cream. He broke his piggy bank today and got a 20 rupee note and a 10 rupee coin. Bablu decided that he would buy ice cream from his money in such a way that no money was left. Bablu is thinking,
If I had to buy ice creams at only one price with my 20 rupee note and 10 rupee coin, at what price would I be able to buy the ice cream?
Children, can you tell me how Bablu can find the answer to this question? Exactly. To solve this question, Bablu has to choose the factors which are the factors of both 20 and 10. Can you tell which are the factors of both 20 and 10? If you want, you can pause the video and find the answer. He first wrote the factors of 20 in this way. Now Bablu wrote down the factors of 10. Yes, these numbers 1, 2, 5 and 10 are factors of both 20 and 10. And kids, do you know that factors that are factors of more than one number are called common factors of those numbers? If Bablu had 50 and 15 rupees, then at what prices would Bablu have been able to buy? If you want, you can pause the video and find the answer. 1 and 5 are the common factors of 50 and 15. So Bablu would have been able to buy ice creams for 1 or 5 rupees. Bablu bought 2 10-rupee Chocobar ice creams from his 20-rupee note and a 10-rupee Chocobar ice cream from his 10-rupee coin. And together with Pinky and Raju, they ate ice cream with great pleasure. Children, in this video, we learned what are common factors. In the next video, we shall learn more about it by using some interesting examples. Hello kids! In the previous video, we learned more about common factors. In this video, we will learn more about common factors by some interesting examples. Golu has 12, 18 and 24 liters of milk filled in different pots. But Golu doesn't remember which utensil has how many liters of milk. Golu is thinking that he will measure the milk of all those utensils using a single vessel. Children, can you tell us what capacities of utensils can Golu use? If you want, you can pause the video and find the answer. First, we will write the factors of 12, 18 and 24. What do we have to do to find the utensils that Golu can use to measure milk? Exactly. We need to find common factors of 12, 18 and 24. 1, 2, 3 and 6 are common factors of these numbers.
I can easily measure the milk filled in these pots using a pot of 2, 3 or 6 liters. And the largest of these is a capacity of 6 liters. So we can definitely measure the milk filled in these utensils with a 6-liter vessel,
thought Golu. Children, out of the common factors of numbers, the largest number is called the highest common factor. Out of all the common factors of 12, 18 and 24, 6 is the largest. Therefore, we can say that 6 is the highest common factor of 12, 18 and 24. Golu began measuring the milk filled in all those pots with a 6-liter vessel. To measure the milk filled in this vessel, Golu used that 6-liter pot twice. For this pot, he used the 6-liter pot 3 times. And to measure the milk filled in this pot, Golu used his 6-liter vessel 4 times. In this way, Golu came to know that 12 liters of milk are filled in this pot, 18 liters in this one, and 24 liters of milk in this pot. Children, if Golu's pots were filled with 30, 42 and 48 liters of milk, can you tell what capacity would be used? If you want, you can pause the video and find the answer. These numbers 1, 2, 3 and 6 are the common factors of 30, 42 and 48. Out of them, 6 is the highest number or the highest common factor. Therefore, Golu would use only a 6-liter pot to measure 30, 42 and 48 liters of milk. Golu measured the milk filled in his pots and labeled them in this way so that he again does not forget the amount of milk filled in them. Children, in this video, we learned more about common factors by some interesting examples. In the next video, we will see some interesting concepts related to this. Hello kids! In the previous video, we learned more about common factors. In this video, we will see some interesting concepts related to this. Golu, Bhola and Bunny together have decided to donate some items to the needy children of Champapur. Golu will bring pencils, Bhola will bring pens and Bunny will bring notebooks. Then, all three of them will divide those things equally among the number of children so that every child gets every item. Golu has brought 19 pencils, Bhola has brought 48 pens and Bunny has brought 54 notebooks. Now all three friends are thinking as to what is the maximum number of children that they will be able to give these things to. To find a solution to this question, Bunny first wrote the factors of the three numbers in this way. Now, Bunny is trying to find the common factors of these numbers. Bunny is thinking,
There is only one common factor of these numbers. 1. How can it be possible that 1 is a factor of each of these numbers?
Children, is what Bunny saying correct? Is 1 a factor of every number? We can divide any number by 1. So 1 is the factor of each number. Bunny's point is absolutely correct. Now, all three friends are thinking that they cannot give all those things to only one child. And 19 has only two factors, 1 and 19 itself. So those numbers and shared factors are not possible.
But why does 19 have only two factors?
Bhola asked Bunny.
There are many numbers like 19, which we can only divide by 1 and that number itself. We call such numbers prime numbers. And because these numbers can only be divided by 1 and that number itself, they have only two factors.
Bunny explained to Bhola. Golu told Bunny and Bhola,
I have a solution for this. Why don't I add more pencils to these? so that we can get even more common factors in these three numbers.
Bhola and Bunny liked Golu's suggestion very much. Bhola immediately found the common factors of 48 and 54.
Look guys, these numbers are the common factors of 48 and 54. And 6 of these are the highest common factor of these numbers. So, we have to increase the number of Golu's 19 pencils in such a way that even that increased number has 6 as a factor.
If I add one more pencil to these 19 pencils, then the total is 20 pencils. But 20, 48, and 54 do not have 6 as a common factor. If I add one more pencil, the total is 21 pencils. But now also we are not able to get 6 as a common factor. Will we get 6 as a common factor in 22 and 23?
Golu asked Bunny and Bhola.
No,
Said Bunny.
Oh wow! If I add 5 pencils to 19, there will be a total of 24 pencils. Here, the numbers 1, 2, 3 and 6 are the common factors of 24, 48 and 54. And 6 is their highest common factor. Therefore, we can distribute these things equally among 6 children.
Children, can you tell how many pencils, pens and notebooks each child will get? If you want, you can stop the video and find the answer. 6 times 4 is 24. So every child gets 4 pencils. 6 times 8 is 48. So each child gets 8 pens. And 6 times 9 is 54. So every child will get 9 notebooks. In this way, Golu, Bunny and Bhola formed 6 groups of all those items. And excitedly, they went out to deliver them to the needy children of the village. Children, in this video, we have seen some fun concepts related to common factors.